Friends of chemistry.
What
Martin
up,
and I.
dogs?
Yo. Martin and I are doing on your own 15.
Ow, ow, Mom.
Hey man, I was hip before hip was hip.
Ow.
Okay, we're doing on your own 15.7. Martin, will you read it to us? I've already got part of it written on the chalkboard.
Took out the bookmark again.
I did. I take them on all the time. I'm bad. I'm bad that way. I'm bad. She's really bad.
Chemist is studying the following reaction. It's at the top of the board.
Read it again.
2NH3 gas is in equilibrium with N2 gas plus 3H2 gas. The reaction has an equilibrium constant of 17 molarity squared. The chemist measures the concentrations of each substance to be the concentration of NH3 equals 0.40 molarity. The concentration of N2 equals 1.5 molarity. The concentration of H2 equals 1.3 molarity. Is the reaction at equilibrium? If not, which way will it shift in order to attain equilibrium?
All right. So how are we supposed to calculate K? What's equation 15.2? Capital letter K, the equilibrium constant.
Yep.
Is the concentration of C at equilibrium.
Yep.
Times the lowercase c. Exponent, not times, to the exponent, whatever lowercase c, times product D, concentration at equilibrium, to whatever the coefficient of product D is, to its exponent, over concentration of A
equilibrium to the power of A, times the concentration of B at equilibrium to the power of lowercase b.
Right. And these lowercase numbers are the coefficients of the substances in the chemical equation.
Okay. So
when we calculate K, it's going to equal those at equilibrium. So we have to say are these those concentrations? Does this equal K? So we have to calculate this and find out if it equals 17 molarity squared. So let's begin. What do we have for C? What's our substance C? It's going to be this, right?
Yeah.
What's the concentration of the N2?
1.5.
Right, so it's going to be 1.5 molarity.
Yeah.
What is the coefficient of the N2? It's 1, so it's just to the 1 power.
Yeah.
What's the next substance that we have?
H2.
So that's our D, and its concentration is 1.3. What is the coefficient of the hydrogen?
1.
No,
3.
The coefficient of the hydrogen here, look, is 3.
Yeah.
So this has to be cubed. Okay? And this is all going to be divided by, there's no B substance, there's only an A here on the reactants side of our equation. So we're just going to say the concentration of NH3, which is 0.40 molarity, and that will be to this coefficient 2, so it's going to be squared. Okay, so now we're going to use our calculator. We're going to have to use a lot of parentheses to set this up properly. So I'm going to say open parentheses, 1.5 times, open parentheses, 1.3 cubed, close parentheses, divided by, open parentheses, 0.4 squared, close parentheses. And I get 20.59. So I get 20.6. How many significant digits do I want?
2.
I only want 2, so this will be 21. And let's check our units. This is molarity squared, so that just becomes, that's molarity times, so this will be molarity squared. Okay? So we're going to end up with 21 molarity squares. So this is not equal to this K, is it?
It is not.
Okay, so these are not the concentrations of the reaction at equilibrium.
Nope.
So here the K is higher, right, than the actual K.
Yep.
So in order to reach equilibrium, we have to change the concentrations so that the value of the equation will decrease. So
Yep.
looking at the way this math is set up, how can you make the value decrease?
You gotta shift it towards the reactants.
Yeah, we want the number on the top, the numerator, to become a smaller number, right?
Yep.
Or the number on the bottom to become a bigger number. Either way, that means that we want to shift towards the reactant side. This side of the equation has to have a higher concentration so that this number can get smaller. Make sense?
Yeah.
Excellent. That's it for this video. We'll come back with 15.8. Yeah. Yo. Oh, sorry. I'll stop now.